Hello, hello, good afternoon or good evening. Okay, so let me just record a couple of these questions. Word problems, word problems, elevation, back side of quiz, law of cosine, number 4, 5 on classwork. Okay, all right, so let me find the classwork one first, and then we'll get going. Okay, so let me find all these stuff. Let's see. Sorry, I'm just finding a couple things. Okay, so we should have, oops, oh no, something happened. I think for most of the teachers, we confirmed that we are taking the quiz or the test on Wednesday due to the fact that we have a fire drill during third period tomorrow, so it's a normal schedule, and just your third period class will be a little shorter. So we felt it was unfair if we gave the test tomorrow to those third period students. So therefore, no test tomorrow. So it got moved one day, okay? All right, so I think I got questions up until V. Okay, all right. Okay, so let's get started. Sorry, guys, a little delay. I'm going to start with some word problems and then the back side of the quiz. So the word problem, let's see. This might help two people at once. I think, is it maybe Alex? No, who was it? It is, oh, Andrew, I'm sorry, Andrew or Kyle. Okay, so I'm going to do this problem number 1, 2, 3, 4. Okay, so let me copy and paste this into here. Oh, I didn't do it. That is a bummer. Maybe if I do this. Yay! Okay, so here's the situation. Top of a spire, 50 feet, angle depression, to 2 cars on a straight road at the same level. A spire is a tower. Okay, so the angle of depression to one car is 25 degrees. Angle of depression to the other car is 40 degrees. So some teachers, like Miss Bratcher, I know, teaches angle of elevation, same thing as angle of depression. But let me just draw the situation, and then we could do the math after. Okay, so here's the spire. Okay, here's the spire. And from the top of the spire, so 50, we have an angle of depression. So that means the horizontal to the diagonal. This angle here is 25 degrees. So this is the road. This is car number 1. And then from the same exact location, we're looking here, and that'll be 40. So this is 40, the red angle is 40. And then the green angle to the car is 25. This is car 2. The word problem got cut off, and so calculate the distance between the 2 cars. Okay, between the 2 cars. So this is definitely SOHCAHTOA. And if you were to put the angles like Miss Bratcher does and Tara does, you could put the angle of elevation as well to car 2. And you can put the angle of elevation to car 1 to 25 degrees. So you can, it's interchangeable. You can have it, because here's the big idea. If this is angle of depression, this is angle of elevation, they're congruent since they're alternate interior angles. So if you see the word angle of depression, you could equate it to angle of elevation, okay? So from here, we're trying to calculate this distance right here, this yellow zigzag distance. That means we have to do trig twice. So we have to calculate this amount from the spire, the bottom of the spire, the tower, to car 2, call it x, and then do it again from the bottom of the spire to car 1, call that y, and then after we subtract them to calculate the distance between the two cars. So if I drew just one of the triangles, here's the 40 degree, and here's x, and here's 50. That means this has to be tangent, because from the 40 degree, we got opposite over adjacent. So the math here has to be tangent 2 times, okay, 2 separate pictures. And then let me just redraw the other picture. Let's see. So again, you could put the angle of elevation as same as angle of depression. That's 25 degrees, still 50, and then we're going to call this y. So this is tangent 2 times. We're calculating x, we're calculating y, and then subtracting them afterwards. Okay, so hopefully you kind of see the picture. I'm going to go to the next page. If you want to take a picture of the screen, you can, but I am going to go to the next page to show the work of how to continue this process. So ready, 1, 2, 3. Okay, so the first picture was 50, this is 40 degrees, and x. So this has to be tangent of 40 degrees. And that's equal to opposite, which is 50, over adjacent, which is x. In this scenario, this is just regular SOHCAHTOA, so you cross multiply and get it calc ready. So I'm just showing all the work. Some of you already know what to do. You already found the answer. I'm just showing every single step. So I cross multiplied, that's the answer. Okay, I need to get rid of tangent 40, so I got to divide by tangent 40. So that's gone, and now it's on the other side. So put that in the calculator. Oh, darn, I didn't bring my calculator. Let me see. Oh, so let's see, 50 divided by tangent 40, that is about 59.58. I'll round at the end, so 59.587. Okay, and then I'm going to do it all over again, but with the other picture. So that one was 25 degrees. And y, and 50. So that is tangent 25 equals 50 over y. It looks the same as the other one, so I'm just going to get it calc ready form right off the bat. Y is 50 divided by tan 25. Put that in your calculator, and it should be more. And that's 107.225-ish. Oops. So now we're going to subtract these. So going back to the old picture, we found all the way to car 1, and we found all the way to car 2, and we have to take the difference. We're subtracting them. So that means 59.58. I'm just writing all the digits. I think V said you could write it as 59.6. True. I just like to keep all my digits intact until the very end. 107.22 something something. So it won't make a difference because you are rounding to the 10th. This one is going to be 47.6. So if we drop this and we made this a 6, this would have been the same. Yep. And I forgot what the units were. Going back. And that one was feet. So from car 1 to car 2, it is 47.6 feet apart. I'm going to do another one that's angle of depression or elevation, and then I will do the backside of the quizzes and some law of cosines. Okay, let's see. Okay, just checking if there's any new questions. Nope. Okay. So another question. Let me just copy and paste from what I have earlier. Let's see. Oh, this is a good one. This next one. Okay. All right. Copy and hopefully pastes for us. Yay. Okay. So here's the next one. Angle of elevation of an unfinished tower. So Kyle, please let me know if this is the right one, because I didn't number the classworks and I have a digital file, so hoping this is the right one. So if Kyle is still here, please confirm. Okay, here is an unfinished tower. So this could keep getting higher, okay? So the angle of elevation, thank you, from a point 120 meters away. So let's say this is 120 meters away. This is the tower. From its base is 25 degrees. Okay, so from here to here, let's say, is 25 degrees. And this is unfinished, so this keeps growing. Okay, how much higher the tower be raised so that the angle of elevation from the same point would be 40 degrees. So we want this to be higher, this red to be 40 degrees. So the big goal is to figure out how much taller, how much more do we have to raise the tower? How much more do we have to build? How many more layers? So essentially we are finding X from using the 25-degree picture, and we're going to find Y. So it's just like the car 1 and car 2 situation, and that's the 40-degree picture. So after you find those two, then you can subtract those numbers. So this is SOHCAHTOA again. It looks like it's tangent once again, opposite over adjacent. So from this 40-degree angle, we are going to label across the street or opposite. So this picture here, the first picture for Y, sorry, I was just coughing, so I muted. Okay, so this one is tangent 40 degrees equals to Y over 20. And then for the other picture over here, it's tangent 25 degrees is equal to X over 120. And once we get X, once we get Y, then we subtract them, and we'll get how much more do we have to layer up. So I think the hardest part in these questions is to draw it and to figure out what it's asking for. Is it the vertical? Is it the horizontal? So I think pictures are very helpful, and you have to imagine what the situation is. Okay. Okay, so now calc ready form. So let me delete the pictures because I don't have much room. Here. Let's see, it's very slow. Oh my gosh. Sorry, everything's going crazy. Okay, so when you're putting this in your calculator, you're going to cross multiply once again. You're going to get Y equals 120 times tangent 40. You plug it in, 120 tangent 40, and you get 100.7. I'll round this time, 100.7. Then you do it again with the X situation. You'll get X equals 120 times tangent 25. and that'll be smaller because it didn't get as high. That's 55.95. I guess I'll round up to 56.0. And then I'm going to subtract those numbers. So earlier was 100.7 minus 56.0. And our grand finale answer, that green zigzag area, is 44.7. I don't know if it's meters or meters. I see the bottom. Okay, so it's multi-step where you have to do trig twice. Sure. Okay, so next one, I'm going to do the quiz. So special triangles. Yeah, you could draw two separate pictures. Oh. 40 and 25. That's an interesting question. Okay, so here and here. So you're saying this is 15 degrees, this is 25 degrees, and this whole thing is 40. So, Kaylee, if you do it this way, if you do the 15 degree, and we are trying to find this amount, here's the only problem is that we were given this bottom segment was 120, but if I were to highlight what I have in this green picture, 15 degree, and we're like question mark, we're gonna be stuck, to be honest. I wouldn't know how to go about this problem because we don't have enough information if we use 15 degrees. If we use this obtuse looking triangle, right, this green triangle that I highlighted, we won't be able to get that directly. So it's great thinking. 15 degrees is the leftover of 40 and 25, but we don't even have any of the other measurements. So unfortunately, we're kind of stuck in that situation. Maybe in a different situation, but yeah, this one we're stuck, unfortunately. All right, I'm going to go to the back side of the quiz. And so there might have been different quizzes. So just FYI, I don't remember who asked this earlier, but your numbers might be different. Okay, so I have number 9, and it says June in Armando. So whoever asked, please interrupt and say, yes, this is correct, or no, this is not the one. So I'll start. Oh, okay. So Andrew, if this is the one, please let me know. Hot air balloon. Okay, cool. It says Armando's balloon is slightly higher. So I'm going to draw A for Armando and J for June. And then the two balloons are 100 feet horizontally apart. It specifically said horizontally apart. And June notices she must look at an angle of elevation. So I could have done it here, 100 as well. Angle of elevation is always the same as angle of depression, but she looked 25 degrees up at Armando. And how much higher is Armando in comparison to June? So we are trying to figure out this zigzag amount, this vertical, how much higher. Whenever it says high or height, vertical. So this looks like, I'll put an X here, and I only need to look at one triangle. And height is always vertical, it's perpendicular. So this is regular SOHCAHTOA. This looks like opposite over adjacent from the 25 degree, big dot right here. It's tangent again. So tangent 25 equals x over 100, cross multiply, x will equal 100 times tangent 25. Put that in your calculator. This is round to the nearest tenth for mine. So this ended up being 46.6. Okay. Let me see. Number 10 through 14. So I'm going to just continue, and then we'll get to law of cosine, okay? All right, so 10, hopefully this matches yours. This is a lifeguard situation. Oops. Lifeguard. Looking down a swimmer. Okay. Your line. Okay, so let's draw the lifeguard, right? So they're up here. So lifeguard, L. And then this is the pool, and this is the swimmer. It says the line of sight forms a 55-degree angle. Oh, and this is really specific with the horizontal line. Like that gave you a clue. Like you got to use that horizontal line. So this is the angle that we're talking about. If you're in Bradshaw or Tirias, you know that you could also use this as 55 degrees down here, right? Its angle of elevation is the same as angle of depression. They're alternate interior angles. So you don't have to label both, but just pick one, okay? It said you are 10 feet up on the seat. So the lifeguard is 10 feet. And it says how far is the swimmer from the base of the lifeguard stand. So how far? So this is what we're trying to find, this distance, the horizontal distance. Base is the bottom, right? So I'm just going to look at this picture on the bottom right here. I don't have to look at the angle of depression. I could look at angle of elevation. So guess what? This is tangent again. So we're going to do tangent. 55 degrees equals 10 over x. Cross multiply. It's not ready yet, right? So x times tangent 55 equals to 10. Get rid of that. So x is equal to 10 divided by tangent 55. This is from the quiz. And this answer was, if we rounded, it had to round up. So answer was 7.0 feet, or just 7. But if you want to be, saying, hey, I used a 10th place, there's that 10th place. So it did round up. Okay. All right. The next one is number 11. So I'm going to continue to 14. And then we'll do some law of cosine and some special triangles. Okay. All right. So the next one is number 11. This one's a good one. Okay. This is kind of like the car one, and kind of like, so earlier if you were joining us, I did 2 word problem ones with angle of elevation, depression. So that one is just like that. Okay, so 11, it says a 10-foot ladder, I think this was on a homework too, is against a wall. So, already you're reading it, kind of understanding the question. So here's the ground. Here's the wall. And the 10-foot ladder, it's not those adjustable ones, it's just purely 10 foot, okay? So it is 75 degrees. This is the ladder. 75 degrees with the ground. It was really specific, so angle of elevation. Oops, 75. Okay, but the ladder slips down the wall, and now it's 50 degrees. So it's still 10 foot, okay? But now it went down the wall and it's 50 degrees. So there's 2 right triangles in this situation. Question is, how far did the ladder move down the wall? So from start up here to finish right here, how far did it move? And so we were trying to figure out the zigzag. So I'm going to redraw the red picture. That's the 75 degree. This is the ladder, 10 feet, okay, and 75. And we're going to calculate how high it was against the wall. I'm going to call that y. And then I will draw the green picture, which it slipped down a little bit. Oops, that's too much. Slipped down a little bit. And this is now 50 degrees, still 10-foot ladder. That didn't change. And then I'm going to call that x, so finding this amount. So lastly, you're going to try to figure out this leftover, and we'll subtract y minus x. Okay, so this is not tangent this time. This is sine. This is opposite over hypotenuse from the angles. So sine of 75 equals y over 10. So calc ready would be y equals 10 times sine 75. And then we do that again over here. Sine 50 degrees is equal to x over 10. Again, it's sine because opposite over hypotenuse from the angle 50. Calc ready is 10 times sine 50. So the first answer, that was about 9.7. So it has to be less than the hypotenuse, right? Because hypotenuse is always the biggest. And then the 50-degree one, that was up the wall about 7.7. So we're going to subtract those two numbers, and that is 2.0. So 2.0 feet is how much it slipped down the ladder, down the wall. So this is the amount we wanted to figure out. So there might be a lot of those, to look out for, where you have two right triangles to look at and then subtracting them. Okay, then we have number 12, 13, 14, and then on the quiz, now do some log, cosine, and special. So 12 was, a lot of us, I think, assumed, but you assumed correctly. So there were these parallel, and yes, these are all 45, 45, 90s due to the fact that these were parallel and due to the fact that these were congruent. So let's start slow, okay? We know over here on the very right bottom, these are 45, 45, 90 because of the tick marks. It's isosceles right triangle. Then we know the top and bottom bases are parallel, so it's maybe a trapezoid or some sort. So that means if this angle down here is marked, that means this angle here is marked as well because those are alternate interior angles. And we know that these three are now congruent, so that forces them to all be the same. So this is 45, this is 45, this is 45. So we got another isosceles right triangle. Okay, then because we know this original one's 45 and 45, and look at how we have four total angles here. We got 45, we got 45, we got 45. This has to be 45 as well, right? To add up to 180 degrees, linear pair, or not linear pair, but just a line. So that forces this other angle to be 45, and this forces this angle to be 45. So if you assumed it, you were lucky. I just hope that you kind of thought it through because it might not always be 45, 45, 90. We're just lucky sometimes. Okay, so let's get rid of all those 45s because now it's really cluttered. And now that we know they're all isosceles, we can just multiply by rad 2. So this is step 1. Finding this hypotenuse is 5 rad 2. And that forces this to be the same because they're the legs. And then to find this new amount, we do 5 rad 2 times rad 2, which is 10. That forces the other leg to be 10. And then this hypotenuse here would be 10 rad 2. I forget what we're trying to find. We're trying to find this x. This other leg is 10 rad 2. So lastly, this bottom red one that we really wanted was 10 rad 2 times rad 2, which is 10 times 2, and that is 20. So hopefully you utilize those parallels to confirm that it is isosceles right triangles. Okay, that's number 12. Number 13. This one is a mix of two problems, 8, 6, 45. So I know Kyle asked about if we could do some special right triangles. So here we are, but first we have to figure out this red hypotenuse segment using this red triangle. This is not trig. You could, I wouldn't use trig, but you can use it. The easier way is to do Pythagorean theorem. And we're trying to find the hypotenuse. So 6 squared plus 8 squared. It's a triple. So if you know your triples, 3, 4, 5. We'll call this C. So it's just doubled. Okay, so C is equal to the square root of 100, which is 10. So it's 3, 4, 5, but it's doubled 6, 8, 10. Okay, so we got that hypotenuse. Now we don't look at this. This is done. Now we look at the 45, 45, 90, and to go from hypotenuse to leg, we divide by rad 2. So then the answer is 10 divided by rad 2, but in algebra, in mathematics, we don't like, or we can't have a rad on the bottom, kind of like can't have a 0 on the bottom. So then that means the final answer is almost there. Our final answer is 5 rad 2. So final answer, 5 rad 2. Okay, besides sine and cosine, there can be only correct. Yes, there's no other special right triangles, Ryan. There's only 45, 45, 90, and 30, 60, 90. So let me finish one more on the quiz, unless you guys have more questions. But number 14 was a multi-step as well. It was a 30, 60, 90. I'm surprised no one asked for 15, but that's cool. Okay, so here's 60, 10, 4, 90. 90 is a trapezoid, and y. So when you see this, I'm like, ooh, a 60 degree. It's triggering my mind to use 30, 60, 90 somehow. So when that triggers my mind, I say, I need to draw a right triangle. So I do that right here. Here's a 90, here's a 90, here's a 90. So on the right side, I have a rectangle. On the left side, I have a 30, 60, 90 triangle. So you could throw in a 30 here if you want. So now I know that the right side is a rectangle. So if the top base is 4, this bottom base is 4. But that's all I know so far. So then I can't do anything with the rectangle anymore for right now. I'm going to look at the 30, 60, 90 triangle. And since I'm given the hypotenuse, right, originated from an equilateral triangle, so I'm just giving a developing stage. You're given 10. So if this is originally equilateral, all sides are 10. And only for equilateral or isosceles, it bisects the base. So this is 5. In other words, you're dividing by 2. So this bottom is 5. Hey, we could solve for y now. Add the blue and the green. So y is equal to 9. Okay, so now that's done. Y is done. There is an x somewhere. Oh, x is over here. So now if I go to try to find the altitude of a 30, 60, 90, I multiply the smallest side by rad 3. So this would be 5 rad 3. And guess what? This here is a rectangle. So x, no thinking, well, there is thinking, but no math, no more math. It's the same measurement. So 5 rad 3 is the grand finale answer for 14. Okay, the next question was law of cosine, and then let's do some special triangles. So law of cosine, let's see. Let me find, I don't want to just make it up because it might not work. I've done that before, and it's like, oops, domain error. It's because it's not a good triangle. All right, so let me find the good law of cosine from the textbook. It was the most recent lesson. Gotcha, okay. So let's see. I gotta think which one will require law of cosine. Okay, let's do this one. So we have x, 7, 48 degrees, and 10. So, rule of thumb, just try law of sine. So law of sine is sine of 48 over the opposite side x. And then now we're stuck because we got the bottoms, right? But we don't have the angles for those opposite side. So even if we did the first two, we're stuck because we have 2 unknowns and we can't go forward. So law of sines don't work. So we erase it. Then we say, okay, let's try law of cosine. So let's assign letters to all the angles. Since the opposite side's x, I'm going to call 48 degrees x. And then I could call all the other ones whatever I want. So from there, now on the opposite side, name it the little letters, just so it's easy to associate. Okay, here we go. The formula, we're trying to find little x, law of cosines. Law of cosines, that's for non-right triangles. Whoa. And it looks like Pythagorean theorem at first, and then you subtract 2 times y times z times cosine of the angle that we're trying to find, x. So law of cosine in this, if you're trying to find a side, we would be able to plug in all the numbers. So 7 squared is y squared, 10 squared minus 2 times 7 times 10 times cosine 48. Depending on your teacher, some of you might enter it all separately. For me, I just enter it all at once with the calculator. So I type 7x squared plus 10x squared on the calculator minus 2 times 7 times 10 times cosine 48 degrees, and I hit enter. So I am getting this really big number, and that doesn't make sense. I'm not done. How can x be 55 when everything else is only 7 and 10? That won't be a triangle. So we're almost done. What you need to do is take the square root of your answer. Now this keeps going, and it is best to round at the end. I'm sure all your teachers would appreciate that. I know me, I want my students to have the usage of this button in the calculator. So what you will do is you would activate the square root button, and then that 55.3 disappeared. So because that was the most recent answer, you would push second at the very bottom next to the equal sign. This is answer. And then you would get about 7.437 dot 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 dot. So I only need 10th place. So my answer will be 7.4 for this situation. And that makes sense. It's in range. It's not ridiculously big. It's not like extremely small. And you will be asked this question where this is 7.7, 7, and 10. Is this a possible triangle? This is from last semester. You have to use the triangle inequality theorem, which means you will have to add the 2 smallest sides, and that has to be greater than the biggest side. And this is true. 14.7 is bigger than 10. So that means, yes, it's a triangle. But earlier, if this was 55.3, I forgot the decimal, it wouldn't have worked. Because, oops, that's still 7.7. It wouldn't have worked. So you're like, wait a minute. So then you're like, oh, I forgot to square root it. Like, try to look back at your picture and make sense of the number. Don't just say, punch in the calculator and done. Like, you have to reason through it, okay? That's my biggest advice. All right, so let me do one more law of cosine, and then from there, we can do some special triangles and number 12. Sure, okay. Let me find one where it asks to find an angle. I think I found one. Okay. So here is 20, 12, and 14. Let's find this angle. Let's call it x, y, z. So let's find measure of angle x. Okay, so I'm going to show the long way, and I'm going to show the fast way. So here's x, and y, and z. So the long way is done this way, and we're trying to figure out this angle. If you're given side, 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 meaning all 3 sides are given, it is law of cosine every time, okay? I'm going to show the short way. Some of my students already know the shortcut. They're already plugging it in the calculator. They're getting an answer. That's fine. But I'm just going to show, just in case not all teachers showed it this way. So you do the original law of cosine. And the only thing we don't have is this angle right here. We have everything else. So if you're trained this way, just continue to do it. But in a little bit, I will show you a fast and direct way. And if it makes sense to you, do it. If it doesn't, do your old way. So some people, they calculate all of these, and that's fine, right? They calculate every single thing, and then they get one fraction in the end, and then they solve, right? That is totally fine. So you're doing a lot of algebra. Now, if I wanted to isolate cosine x, I'm going to show the shortcut now, okay? So let me copy this down. 20 squared equals, oh, I already forgot the numbers. 14, 12, okay, 14 and 12. Okay, so, oops, if I wanted to move these over, I would do 20 squared minus 14 squared minus 12 squared, right? So now they're gone. They're gone. I'm just showing a little bit of algebra. And then this is a product, -2 times 14 times 12. So to get rid of it from cosine x, right now it's getting multiplied, we're going to divide it. So this is -2 times 14 times 12. And now that's equal to cosine x. And in order for us to detach this word cosine x, we take the inverse, so that crosses it out, but now it's in front of over here. So this is what we're trying to type in the calc. So if you are trying to find a capital angle x, the formula, I know McKee does a different formula, but this is Tira's formula. You would have x squared first, and then the other two letters you're subtracting. And then the bottom is -2 times y times z. I think McKee's is very similar. And I'm not sure Bratcher showed this. I'm not sure if Higgins showed this, but if you have a McKee, please help me out here, okay? I know the bottom was 2 and probably YZ, I think. And the top, I want to say, let me think about it, was y squared plus z squared minus x squared. I want to say that's what McKee does, but I don't recall 100%. But I feel like that math is accurate. So I don't know the exact formula, but no one is confirming. Oh, that's right. Okay, so if you are a McKee student and you learn that fast shortcut, they are essentially the same because to get rid of the negative on the bottom, you're trying to take away a negative from the top. So it changes the sign for all of them, and then it cancels. So I really like that formula more, but I did it the other way. Okay. So anyway, we are punching all these in the calculator. And if you're getting domain error, that means you're not using a parenthesis. So I recommend, especially my students, if you get domain error, calculate all the top answers, write your number down. Calculate all the bottom answers, write your number down. That's my big, humongous suggestion, is if you're getting domain error, or if you feel it's not reasonable, or if you have time, like 5 more minutes, 10 more minutes, check it. Check your answer. Don't assume you typed everything correctly, and don't assume it's 100% until you tried it a different way. So what I'm going to do right now is I'm not going to put it in all directly. I'm going to calculate just the top answer. This is using my formula, okay? So I have inverse of cosine on the top is 60, and on the bottom is -336. You don't even have to reduce. I recommend you not to, because what if you reduce wrong? So, but if you want to do it multiple ways, feel free, okay? So I'm going to do inverse of cosine, 60 divided by -336, and I get 100.3 degrees. So 100 degrees if you're Tira Bratcher, or McKee might want 10th place, I'm not sure. So just always read your directions. And that seems pretty reasonable, okay? Because if you look back at your old picture, 20 was the biggest side. So this should be the biggest angle. So it's okay if it's obtuse, okay? So that's the law of cosine. So how about this? I want you guys to think, if we have this picture, don't do the math, but if I had this picture, this has to be bigger, so 9, and I'm trying to find capital X. So I just want you guys to think of how you would enter this if you have, right, this situation. So just kind of think about it. I'll give you about a few seconds. What would you enter in there? You don't have to calculate the answer. And it might be different from other classmates. But if you have the direct answer, you could do this old-fashioned way too. Right? Think about it. I'll start writing what I would in black. So that would be for tiras. This is what we're used to. We have to put 14 square first because it's x. And I don't care about the other ones after. And negative 2 times 9 times 8. Okay, I'm going to think how McKee's would do it. McKee would be 2 times 9 times 8. And it would be 9 squared plus 8 squared minus 14 squared. So I think McKee's, he puts negative x squared at the end when we're trying to find x, versus Tira puts x squared at the front. And they're all negative. So it's a little different. Otherwise, and if you did the old-fashioned way, you would type in, 14 squared, 9 squared, 8 squared, minus 2 times 9 times 8 times cosine x. And then you will work backwards slowly to calculate x, capital X. Okay, all right. If you have another specific law of cosine, law of sine, any of that sort, please let me know. Type it in. But I will do number 12 from worksheet 8.4 to 8.6 now. Let me check in 8.4, 8.6. Okay, so this was probably homework from last week, I believe. And it was the worksheet. So I'm looking for the digital file so I could just copy and paste it. Okay. Number 4. Wait, what number was it? Oh, 12. Oh, I read the wrong number. Okay. Number 12 is the last question. This one. Oh, I think we just did this, no? So confirm if yes or no, do we do this? So this one was angle of elevation, unfinished tower. So I'll just redraw the picture really quick and show the math, but we just did this. So this one is tower. This is 120 meters from the point to the base. And this is, it's a little different. Maybe the angles are a little different. Oh, okay. I was thinking the quiz. The quiz had this specific question. Oh, this was the latter one. Okay, anyway. Feels like this is familiar. Okay, so that's 35 degrees. Then, and then we start from the same exact spot, and then we go 20 degrees. So we're trying to find x, we're trying to find y, and then we'll find the leftover. So if we look at the small picture, 20 degree, 120, and x. Look at the bigger picture, 35, y, and 120. And then ultimate goal is to find the leftover. So this is both tangent. So tangent 20 equals x over 120. Tangent 35 equals y over 120. Calc ready is 120 times tangent 20. So that answer is, oh man, that's weird. Oh, I put the numbers in wrong. Is 43.7. So 6, 7. And then for y, the taller one, That's 120 times tangent 35. Oh, no. And that should be 84.002. So you're going to subtract those numbers. 84.0 minus 43.7. And that answer is 40.3 meters. So that's how much more you need to layer up on the tower, how much more you need to build. Because it's unfinished, so you still need to purchase material and still build. All right, okay, any other questions? So we did a lot of SOHCAHTOA. We did a lot of trig. Oh, I forgot the special triangles. Let's do those. We did a few special triangles, but I have a challenge one we could do too. Okay, so let's do special right triangles. Here's 60, and then here's 45. And then let's do another. Okay, what should we give? I will give, this is 15. Let's find x right here. Okay, step 1, we got 30, 60, 90. To go from 30, 60, 90, this is the ratio of the parts. So we have to divide by rad3 to get to that small end, and then multiply by 2 to get to the hypotenuse. So the answer here is 15 divided by rad3. Then you rationalize the denominator. And then the final answer is 5 rad3. That's the bottom, okay? This part, 5 rad3. Then we double it. So then we just multiply the 5 only. So the hypotenuse is 10 rad3. Ooh, this is a really ugly answer. Okay, then now we're looking at the 45, 45, 90. So we're given the hypotenuse is 10 rad3, and the ratio of the 45, 45, 90s is the legs are the same, and then the hypotenuse is times rad2. So we're going backwards. We're going to try to find this length. So we have to divide by rad2, and that's ugly. So 10 rad3 divided by rad2. Can't have a rad2 on the bottom, so we're going to multiply top and bottom by rad2. Sorry, it's overlapping. And that means that green portion is 10 rad6 over 2. Oh, it's not as bad. And then reduce the outside numbers. So this number is equal to 5 rad6. Okay, so that green portion is 5 rad6. Ooh, sorry, it's very messy. Okay, but it's good to label every single part of your findings. Okay, it's really, really good to do that. So now our last goal is to find the shortest side. And just like earlier, we have to divide by rad3. So my last math here would be 5 rad6 divided by rad3. You can multiply top and bottom by rad3, or notice these can be reduced to rad2. So final answer is 5 rad2 for this answer. Again, it would have been 5 rad18 over 3. You simplify the rad18. It's going to be a long process, but you'll get 5 rad2 in the end. Okay? All right. Let's see. Oh, here's the challenge I wanted to do. Okay, so let's say I have right triangles, and let's make this 21. And let's put this as 5. Okay, I'm going to build on this. Maybe last one, unless there's a question. Ooh, I did not draw this right. And this is not a rectangle. Okay, let's make this 41. Through. Okay, and then one more is, oh, this is terrible. Okay. Let's pause on that one. Let me erase it. Okay, so let's just find x here, and then we'll build upon it after, because I can't think that far as what other given. So, okay, in this process, you have to do SOHCAHTOA twice, and it is highly advisable to keep your answer button on the calculator. So don't round until the end, okay? Don't round until the end. So if I look at the gray picture, you might want to put like a y here, the hypotenuse. So the gray picture starting at 20, I got adjacent and hypotenuse, which I have to do cosine, okay? So SOHCAHTOA, cosine, the A and H. So that means this cosine of 21 equals 5 over y. And calc ready, I'm going to go a little faster now, is cosine 5 divided by cosine 21. So I'm just going to put in the calculator to see what number it is. It's 5.355, so that makes sense. Hypotenuse is bigger. Okay, so the answer is 5.3557 dot dot dot. And I don't want to round yet, so I'm going to have to use the answer button in a little bit, okay? So y is the answer button. Then if I look at the red picture, if I already have this is 5.377, starting at 41 degrees, I have cosine once again. So I have cosine of 41 equals x over answer, right? It was the 5.377. So now my calculator still has it in there, and I'm going to type calc ready form is answer, which is 5.3557, right, times cosine 41. So I'm just going to hit answer times cosine 41, and that is 4.04-ish. So that's good. It's less than the hypotenuse, okay? So now I have a range of numbers. Now I could extend this picture. So my original goal was to figure out what is, I'm going to call this z degrees, knowing that this is a 3 here outside. So I know I just added that in, but again, I needed to do that because I needed to figure out what those numbers were first. So I'm going to use, I still have my calculator, it still has 4.044, etc. in there. So now my last picture, I'll redraw it just because it looks a little unclear. We have z degrees, we got 4.04, boom, 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 and we got 3 here. So this is going to use sine, since it's opposite over hypotenuse. So sine of z equals 3 over 4.04, but remember that's answer. So z equals 3 over 4.04 with the inverse of inverse of sine, my bad. Sorry, let's start over. So z is inverse of sine of 3 over answer. A lot of answer buttons you want to push, right? So instead of that 4.04, it might not make a huge difference, but maybe 0.1, 0.2. If you round too early, your number at the end might be off by 0.1, 0.2, 0.3. It might be off a little. So this is the most accurate way of calculating that. So okay, I'm going to do inverse of sine, 3 divided by answer. And I get 47.9 degrees. So maybe it wouldn't have made too much a difference if I rounded early, but there are cases, if you round early, it does cause the whole process to be skewed a little bit. It'll be off by a little bit. All right, so rounding is not a bad thing, but I'm just saying if you keep the answer with all the digits in there, it will give you a more precise answer, much more exact answer. So even when you're doing law of sine and law of cosine, right, you want to keep all your digits. All right, well, I hope you guys had a good review. We didn't do any of the acute, right, or obtuse. There might be a question like quiz 1 where it gives you numbers such as rad 7 and 11 and 2 or something, and it'll say, is this acute, right, obtuse, or not possible. Always check not possible first. So that's a completely different picture from these three. This is where you add the two smaller ones, and then it has to be bigger than the third side, the biggest side. So rad 7 is only 2.6 if you put in your calculator. So if I add the two smaller ones, which is, rad 7 plus 2, it's not going to be bigger than 11. It doesn't work. So already it's not possible, because this is what the picture is going to look like. Here's 11, here's rad 7, right, which is 2.6, and here's 2. There's going to be a humongous gap. There won't be enough. Those two sides that are small is not enough to close the triangle. So just be careful. Versus if I put, what would have made it work? Let's say like rad 27. Nope, that's still went rad 47. Nope, that's still too small. So rad 87 would have barely worked. So if I change this to rad 87, now that's 9.3. 9.3 plus 2 is barely bigger than 11. So yes, it's possible. And then now you check, is it right, obtuse, or acute? So always check if it is possible first, and then go forward after. Okay? Any other questions? Sine, law of cosine. Can it be a triple if you have a rad? Oh, yeah. I think so. Let's say, well, this is not the best, but I feel like there is like rad 9, rad 16, rad 25. I know those could be simplified down to 3, 4, 5, so that's a triple. I don't know, we should maybe Google it. It's probably, there was one time, yes. I don't remember the exact number, but I feel like there was one time, yes. I feel like I could make it up. Let's do like 2 rad 2. And that's going to be 4 times just 8. And I feel like there is a situation where you can get it. That's 8. And rad 7. So that's 7. And rad 15. 15. So, okay. So if you had, oh shoot, but I didn't check if it's a triangle. Plus rad 7. Is that bigger than rad 15? Ooh, so this works. So this could be a triple right here. So yes, they're all rads. So if you square them, right, then you would get 8, 7, and 15. And if you add the two smaller ones, it would be bigger than, it would be equal to c squared. So yes, there can be, Sarah. Yeah, so you just have to double check. All right, any other questions? All right, well, you guys have a wonderful evening, and good luck on Wednesday if that's your test day, and almost ski week. So have a good night. You're welcome. I will put the link up. I just stopped the recording.